Okay, number 3. P partitions line segment ST into a 3-to-1 ratio. So that means that we have something like S to T. 3-to-1 ratio, that means we've got 4 parts. So it looks kind of like this, where S to P is 3 out of the 4. So it's kind of like 3 and 1 right here. Now if we look at S coordinate, -5, -6, and T coordinate, -9, +6. Wow, -9, +6. Now it says that, well, let's see, how can we do this? So that's what it looks like. And now if we think about the entire vertical change here, from T to S, we go down 6, then down 6 more, so down 12. So here you have this total from S to T of a vertical move of 12. And let's take the 12, and so we'll give 3 and then 1, 3 and then 1, 3 and then 1, like this. So 9 of that vertical change goes here, and then 3 of that vertical change goes here. So from T to P is a small move of 3, and then from P to S is this larger move down 9. So T to P is just down 3. Now go to the line right here. So it's down 3 and right 1, and there's P. Oh, this is a possible coordinate. Shoot. So this is one way to do it, where we could have P at -8, 3. So the other way we could do this is, instead of doing 3 from S to P and then 1 from P to T, we could switch them. So it could look like this. From S to T, again divided into 4 pieces, and now put P closer to S like this. So here you have 3, here you have 1, and here you have 3. So then thinking about the move down 12, take that move down 12, we'll give 3 of it here and give 9 of it over here. So now from T to P is a move down 9. We'll do this possibility in red. So we'll go to T, and the move from T to P is a move down 9. 3, 6, 9, and go to the line. So there's another possibility for P at -6, -3. All right. The endpoints A and B are partitioned by P into AP and PB, so that AP is twice the length of PB. So AB is partitioned so that AP is twice the length of PB, so it looks something like this. AP is twice the length of PB. Now A is at 4, -8. And B is at -5, 1. Okay, so now the question says, explain by 1, -5 could not be point P. Okay, so looking at this, it looks like this coordinate 1, -5 falls on the line that connects A with B. Yeah, it does. This segment AB has a slope of -1. So let's just call this 1, -5. Let's call that point Q. Now from here, let's do it like this. So we have A and B. And then, so the total move down from y equal 1 to y equal -8, that's a move down 9. So what we would say here is that from A to this partition point needs to be longer than the partition point to B. But you see here A to the partition is shorter than the partition to B. So Q is not the partition because so we will say AQ to BQ equals, so this is a move up 3, or we'll call it down 3 from Q. So this is down 3, and this from B to Q is down 6. So that means that we have AQ in a relationship to BQ of 3 to 6, and that equals 1 to 2, where AQ is shorter than BQ, but we needed from A to the partition to be longer than from B to the partition. So it looks something like this. And this was 3 and 6, which gives us the same as 1 and 2. So now, to answer the question, determine and state the coordinates of P that will make this true. Okay, so from A to B is a move down, from B to A is a move down 9. So then a move for B to P is going to be a move down only, so compared to 1 and 2, right? So we're going to, so 9 divided by 3 is the 3 here. So from B to P is a move of down 3. And then from P to A is a move down 6. So find point P by going to B and then going down 3. And there's point P. So for P we have -2, -2. Wow.